Hi, good morning. Now, our technology is a dye-sensitized cell. It's a third-generation photovoltaic material, and it's capable of producing electricity in both artificial light, i.e. indoors, and low levels of light in outdoor applications. We're based in Cardiff, and you can see there that we have a 120 wind turbine that actually powers the factory. There's quite a compelling message to have this green from green message. At current capacity, the wind turbine will be utilised at about 15% of its capacity on the current manufacturing processes. When the manufacturing plant is at full speed, we would only use maybe 60% of that wind turbine capacity, with the rest being pumped back into the grid. So our mission is to produce a lightweight, flexible technology that can be used in a wide variety of lighting conditions. And we're looking to partner technology companies to integrate our product into their use. Now, the technology was discovered back in 1988 by Professor Gretzel, you see there on the top left. And that is said to have stemmed from his fascination with photosynthesis. Now, in 2006, we acquired commercial rights for this technology, and basically spent the next 5 years producing a manufacturing plant and optimizing the product for commercial use. Just 12 months ago, we made our commercial launch, if you like, and we're now in a position where we're talking to global chip manufacturers, like Texas Instruments, who are producing a power boost chip specifically for use with our technology. I think it's also worth mentioning that Professor Gretzel there won the Millennium Technology Prize in 2010. Now that prize comes with a $3 or $4 million purse, which he then used to invest in our company. So whilst there are other companies out there who use our technology and manufacture our technology, we're the only ones speaking to Professor Gretzel on a daily basis. I'm not a scientist, you have to kind of forgive me on my kind of simplistic explanation of how it works. Basically, you see the sunlight on the top gets absorbed into the dye, this green material, and it excites a number of electrons, which are then diffused through the titanium dioxide and returned back to the electrolyte. Now, it's the movement of these electrons that generate electricity that can then be harnessed. Now, the materials that are used in this photovoltaic cell are very safe and commonly available. The main components are titanium dioxide, which is widely available, used in toothpaste, white paint, etc. And the other is a specifically engineered dye. In actual fact, we could use something like a blackcurrant juice or even tea to actually generate electricity using this convention. What are the benefits? Well, I've got a sample here in front of me. As you can see, it's very flexible, so it can be used in a wide variety of applications that are curved, including things like a solar-powered keyboard maybe, or even a smoke detector. It's very lightweight, very thin, less than 2 millimeters in thickness, and it's customizable in design. So we produce this in rolls up to 500 meters, 11 lanes. It's then cut down to meet the specific requirements of that customer. Now, it does have some additional benefits over silicon, which you may be more familiar with in terms of photovoltaic material. I say the main point that we try to put across, I won't bore you with all this, but it's light performance. It works well in low light conditions. And what we see here, if you concentrate on the graph here on the right, we actually see that the temperature, now this material has a positive coefficient in terms of temperature, whereas the silicons have a negative coefficient. So basically what I'm saying is, the warmer it gets, the better this product performs, unlike the silicon-based products. Now there's a fantastic little quote in here that says, "A battery never puts back as much energy as it took to produce it, and the rest will end up in landfill." Now a piece of this material, the same size as 2 AA batteries, is enough to power a remote control. Now if you look at a remote control, it lays dormant in your home maybe more than 23 hours a day by the time you take into account the amount of times you press a button. So there's an opportunity for it to harvest energy throughout the day, ready for use when you need it. Key markets for us, we've got the likes of bags, iPod cases, mobile phone cases. On the left, standby power for office applications. Now, if you consider the amount of products that are on standby, now in the UK it's something like 18 products are on standby at any one time. In the US, that number increases to 30. So there's a fantastic amount of wasted power that could be saved and powered by this material. And as the technology develops, we can then look at true built-in integrated photovoltaic materials. Some of the outdoor applications that we've used: cycling panniers, mobile phone chargers, bags, and the like. Indoor applications, mentioned TV remote controls, supermarket point-of-sale material, video game controllers, anything that uses a AA battery. Now, as we progress, obviously we're at the early stage of commercialization, and the costs will undoubtedly reduce when we get to the stage where we can mass market the products. Now, the technology is not quite there yet, but future applications could be integrated into body parts of cars. I mentioned kind of true building integrated photovoltaics. And we recently won a contract with a major US hotel chain for 8,000 of their window coverings. Now, the product is used exclusively to power the motorized blinds. Both the remote control that you press the button on to move the blind up and down, and the blind mechanism and the motor itself. As again I mentioned, in terms of future applications, standby power, building integrated photovoltaics. Well, who are we? We're based in Cardiff. We've got a hard-hitting board. You see Ed Stevenson there on the top left. He owns about 70% of the company. And we've got Raikon Gronik, who's a specialist in raising capital for green companies. And we've got Mickey Canton, who's a former US Secretary of Commerce. And as I mentioned previously, Professor Gretzel is the only company who's working on this technology on a day-to-day basis. I'll go through that one. I mentioned we've got a 23-acre capacity, 23-acre campus in Cardiff, exclusively powered by renewable energy and that wind turbine we mentioned. The process that we use to manufacture it is high speed. It's a roll-to-roll process that's very similar to inkjet printing. And we have the capacity to produce about 110 kilometres worth of this material on an annual basis. At current, that could be increased to 500 kilometres with some additional investment in machinery. And that's pretty much enough to satisfy the global market in years to come. We've got a strong focus on R&D. We've got currently 55 employees at the Cardiff site. I think 13 of those are educated to a PhD level. And as the company continues to grow, we have a vision of employing 300 employees. Obviously, the nature of this technology, there's a strong emphasis on the IP. We probably have got 5 years ahead of our nearest competitor in this field. So in summary, competitive advantages in terms of the technology that we have is nearly 5 years ahead of the competition. Exclusive supply chain access at this present time, and high growth opportunities for the future. Thank you very much.